Hello everyone, welcome to Mr. H Math Lab. This video is for 8th grade students and we are review for chapter 4 test on Alex. We're on question number 12. 4 different linear functions are represented below. So they give you 4 different forms of a linear function. It's a graph, a table, a equation, and the description of an equation. Okay, answer the following question. Which function has the graph with a y-intercept farthest from 0? Okay, so y equals to mx plus b, x plus b. Which one is the y-intercept in that form? Okay, as we know that b is the beginning, we always say b is the beginning for the purpose of graphing, and we know that b beginning on the y-axis, that is also your y-intercept. Okay, so what they're asking you is find the y-intercept that's the farthest away from 0. Okay, so we're gonna look at each of them. First one, function a, the starting point is right here. That is 0, 1. So b is 1, or the y-intercept is 0, 1. Function 2, the y-intercept is 0, 4. So 4 is the b. Function 3 is b is negative 2. That is your y-intercept. Right. So that will be negative 2. And the last one, they tell you specifically that y-intercept is negative 5. So the furthest away is negative 5. Negative 5 is the furthest point away from 0. So that will be function 4. Okay, now part B, which function have the graph with the y-intercept greater than negative 3? The y-intercept greater than negative 3. So check all apply. The first one is 0, 1. 1 greater than negative 3, yes. 0, 4 on function 2 right here. So yes, is greater than negative 3. Negative 2 is greater than negative 3, yes, because on the number line you have negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. And negative 2 stay on the right of negative 3, which means it's larger than negative 3. Negative 5 is not, so it's not greater than negative 3, so it's a false statement on number 4. We don't choose number 4. Now, last one, which function graph is the steepest? Okay, which one is the steepest? So which one go further down? So by the steepness, we're gonna look at the slope of each. Okay, so I'm gonna look at function 1. What is my slope here? M equal to rise over run. So you rise up 1, 2, 3, 4, 5 over 1. So slope is 5 over 1, or slope is 5. Okay, number 2 is increasing, the x increasing by 1, right, by adding 1 on each. The y value decreasing by 1. Okay, so slope here is negative 1. And function 3, the slope is 3, m is 3. Okay, and function 4, the slope is negative 4. Okay, so when they say the steepest is how steep, how high up it's gonna go. So as we know that when you graph this is 5 over 1. You go up 5 over 1. This is negative 1. You go down 1 over 1. And this is 3 over 1. So go up 3 over 1. And this is negative 4 over 1. So down 4 over 1. So the steepness, it doesn't matter you go up or down. It's just how far you go, how much do you go up and how much do you go down. So the winner in this case will be m equal to 5, because you go up 5 is the most increasing in the y value, so that's the steepest. So function 1 will be the steepest graph. Alright, now we go down to problem 3. Problem 13. A machine at a bakery is pouring out flour. The graph shows the amounts of flour in grams in the machine versus time in minutes. Okay, so here's the graph. At what time does the flour in machine reach 0 gram? So it's keep pouring. So at what time that's gonna be 0 grams. So we look at the grams. Okay, at 0 gram, it's gonna take 5 minutes. So that would be 5 minutes for 0 grams. Choose the statement that best describe how the time and the amounts of flour are related, and fill in the blank. Okay, as time increasing, the amount of flour in the machine decreasing. As time increasing, 1, 2, and 3, the amounts of flour is decreasing. I can see that. Okay, at first 1 minute you have 560 grams, and at the second minute is 420 grams, and as 3 minutes is 280 grams. So as time go by, the amounts of grams going down, so that's correct, decreasing. As what rate the amounts of flour decreasing. So to know the amounts of flour decreasing, we're going to do is find the slope. So you can pick any 2 points. Let's say if I choose this one, that will be my 1,560. And then the second point going to be right here, that would be 2,420. Okay, to find slope, you're going to do y2 minus y1 over x2 minus x1. So this is x1 y1, this is x2 y2. That will be 420 minus 560 over 2 minus 1. 2 minus 1 is 1. 560 minus 420. That will give me 140. Right? And it's negative 140. So negative 140. So at the answer, you're going to put 140. We don't put negative because they already used the term decreasing, which means negative. And that problem 13. Now we go to question 14. Eric stepped on a escalator moving at a constant rate. The table below show his distance from the first floor after different amounts of time. Okay, so here the table, the first row is go for time, and time go by second, and the second row is for distance in centimeters. Okay, answer the following question. What was Eric's distance from the first floor when he stepped on the escalator? What Eric distance from the first floor when he stepped on the escalator? Alright, so I believe they're asking you for the beginning. So when his first step on the escalator, so it's not really at any second yet, he just stepped on. And what is the distance from the first floor? Distance of him from the first floor. So we're gonna look at the table. As you see that the x value increasing by 3, right? It's increasing consistently by 3, and the y value increasing or decreasing because it's going down. As I see that is 90, minus 90, minus 90, and minus 90. Alright, so we're gonna reverse this. We're gonna keep going. As 6, so plus 3. Which number here at 3 give you 6? That will be 3. And we go back one more time. A number before you add 3 is 0. So we try to find the beginning. This is going to be 0. This is 3. This is 0. Okay. And then we reverse this by what number before you minus 90 give you 1070. So, or the reverse, we adding 90. So that will give you 1160. And then if we add 90 again, that will give you what? 0, 5, 1. That will be 1250. So the distance, what is the Eric distance from the first floor when he stepped on the escalator? That would be 1250 centimeters. Okay, part B, choose the statement that best describe how the time and distance from the first floor related when given value request. So the first one, as time increasing, his distance from the first floor decreasing. So look at the table. At time increasing is recorded by every 3 seconds. The distance is from 1250 turned to 1160, 1070, 980, and 890, and 800. So as you see that the first floor decreasing, the distance from the first floor decreasing. So this would be the correct answer. Okay. At what rate his distance from the first floor decreasing? So it's just asking you for the slope. Similar like the last problem, we're going to pick any 2 points and we're going to find the slope. So I'm going to pick the last two because the number is easy to subtract. 12, 890 and 15, 800. Okay, I'm going to label this as x1, y1, x2, y2. Then we're going to find the slope. M equal to y2 minus y1 over x2 minus x1. So that will be 800 minus 890 over 15 minus 12. So that will give me 90 over 3, negative 90 over 3. That will be negative 30. Okay, and the answer is 30 centimeters per second. We don't put negative because they already used the term decreasing. Okay, decreasing means already negative. Okay, so that's it. Now we go to the last question, number 15. For the function, state whether it is a linear. So a linear function when the setup point decreasing or increasing consistently throughout all points. So first, function 1, we're going to look at negative 3, negative 2, negative 1, 0. So question is, what is the rate of change? What is the pattern here? So it's look like we add 1 for every step. Negative 3 plus 1 is negative 2, negative 2 plus 1 is negative 1, negative 1 plus 1 is 0. And how about the y value? Okay, we have negative 2, 1, 4, and 7. So negative 2 to get to 1, you're going to add 3. From 1 to get 4, you're going to add 3. And from 4 to 7, you're going to add 3. So as you see that they change consistently throughout the setup points, so that will be a linear. Okay, now we'll look at the second function. We have negative 1, 2, 5, 8. Negative 1 to go to 2, you're going to add 3. From 2 to go to 5, you're going to add 3. And from 5 to go to 8, you add 3. So it's looking good on the x values. We're going to do the same for the y. So 3 to go to 4, you're going to minus 1. 4 to go to 5, minus 1. 5 to go to 6, minus 1. So they are consistent, so that will be also a linear function. Okay, let me check it one more time. I want to make sure that I do everything correctly. Okay, 3, adding 4, yes, and this one adding 3, 8, yeah, yes, and okay, looking good. Now we'll go down to the last two, function 3. The pattern of the x value is adding 4, this one plotting 4, and this one also add 4, looking good. 3 to go to negative 2, you're gonna minus 5. Ooh, and negative 2 to negative 5, you minus 3, and from 5 to 9, you minus 4. So they're not consistent, it's not a linear function. Okay, as you see that the y value changing differently every time. Okay, now we go to function 4. the pattern of the x value is adding 4. Oh, the y value is stay consistent. So is that a linear function? Okay, I would say, I would say it is a linear function. Yes, it is a linear function. Because the pattern here is adding 0, it is consistent throughout all points. And that's it. So we have all the answer. If you have any question, please ask me question in class, or you can text me through the Remind if you're in my Remind app. Thank you everyone for watching. Make sure you study, make flashcard, and good luck on Wednesday.